Hi everyone. We just covered the Bohr-Rutherford diagrams, and I'm going to briefly talk about another diagram that I think is useful to know because it's going to help you as we progress on to ions. Okay, so we're going to talk about a diagram called the Lewis Dot diagrams. And behold, they have dots in their diagrams. The Lewis dot is unlike the Bohr-Rutherford because Lewis dot only shows the valence electrons in its diagram. So with Bohr-Rutherford, we showed all the electrons that surround the nucleus. With Lewis dot, we are only going to focus on the valence electrons. So if you'll notice, for hydrogen, when we did the diagram, we said hydrogen had one valence electron. So how would we show that in a Lewis dot? There you go. You put one dot above the H. That shows you that the hydrogen atom has one valence electron. How about carbon? So we did carbon together. When we did the Bohr-Rutherford for carbon, we showed that carbon had 4 valence electrons. Just like we did with Bohr-Rutherford, do not pair electrons unless you've gone one way around. So carbon had 4 electrons, so you draw 1, 2, 3, 4. That shows that carbon has 4 valence electrons. If you had done the Bohr-Rutherford diagram for oxygen, oxygen has 6 valence electrons. So if you were to draw oxygen as a Lewis dot, you'll go 1, 2, 3, 4. Now you pair 5, 6. That is the Lewis dot for oxygen. It has 6 valence electrons. Make sure you go around once before you start pairing them up. It's very simple. Once you've mastered Bohr-Rutherford, it is very simple to draw the Lewis dot. What you will notice, and we like trends, we like seeing patterns in science. As you go down a periodic table, they all have the same number of valence electrons. So if you look at period 1, which has hydrogen, lithium, sodium, all elements in period 1 have 1 valence electron. So if I was to draw lithium, I would draw it with 1 dot as well. If I was to draw sodium, I would draw 1 valence electron. So all elements in the same group have the same number of valence electrons. And that makes it very simple for you to remember. What you'll also be nice to remember is as you go across a periodic table or down periods, you will notice that the number of valence electrons goes up. So let me depict that here for you in a diagram. Unfortunately, I cannot draw an entire periodic table for you. So if you look at group 1, which has hydrogen, lithium, sodium, all of those have 1 valence electron. So all elements in group 1 have 1 valence electron. If you look at all the elements in group 2, which include beryllium, magnesium, calcium, all those have 2 valence electrons. If you then go to group, now some periodic tables will refer to it as group 3 or 13, so there's different ways in which it's referred to, which contains boron, aluminum, and we'll just stop at aluminum. Since it's group 3, it has 3 valence electrons. Let's see if you can catch on to the pattern. If we go to group 4 or group 14, which contains carbon and silicon, do you see a pattern? Can you guess how many valence electrons these elements have? 4 valence electrons. So notice how the group number matches the number of valence electrons it has. And as we move across the periodic table, the number of valence electrons increases. It is a wonderful pattern to remember because it's going to make your life a lot easier in trying to remember how many valence electrons an element has in the periodic table. Find out what group it's in, and then that tells you how many valence electrons are in that element. So let me try one with you. Let me give you an example and see if you can find it out using the pattern. I want you to tell me how many valence electrons neon has. So look at neon in the periodic table. So if you look at the periodic table, neon, which is represented as Ne, is in group 18. But for the sake of simplicity, we refer to it as group 8 as well. So if neon is in group 8, neon is in group 8. How many valence electrons do you think neon then has? 8. So when you draw the Lewis dot for neon, 1, oh, I don't want to mess you up, 2, 3, 4, 5, 6, 7, 8. Now notice you didn't even have to do the Bohr-Rutherford diagram for it to determine how many valence electrons it had. You were able to find out just by looking at the group number. What is very interesting about all the elements in group 8, we talked about them as noble gases or inert gases, is that every element in group 8 has a full shell, meaning 8 electrons. Now, the only other difference is for helium, which has 2, but remember, shell number 1 has maximum of 2 electrons, which is why helium still has a full valence shell. So neon, argon, xenon, all of those have a full valence shell. They all have 8 valence electrons, and they are happy. They don't react with anything because they have 8 valence shells. And we're going to talk about that a little bit more when we start talking about losing and gaining electrons in the next video. But hopefully this allows you to draw your Lewis dot diagrams very easily. I've taught you a trick into how to determine how many valence electrons an element has just by looking at the groups. But please remember, when you're looking at the group number, look at 1 through 8 as opposed to 1 through 18. There's nothing that has 18 valence electrons. So please remember to look at the group numbers carefully when you're trying to determine how many valence electrons an element has. And I hope to see you in the next video when we're going to talk about ions and gaining and losing electrons.